Good morning, students.
Good morning, ma'am.
Myself, Ravinder Kaur, PGT Chemistry. So let's start today's session. But before starting the session, I want to ask you a question. Dear students, if you want to trace a person, then what would you do?
You will identify the city or state of that person.
Definitely, you are going to trace about the city, street, or the house number of that person. Well, in the same case, if I ask you to trace an electron, then what would you do? Don't know. Today's topic is based upon this question. So let's start. We are going to study about quantum numbers. Now the question arises, what are quantum numbers? These are the set of 4 different numbers which will give the complete information, complete address of an electron. Now here the address of the electron means the energy of the electron, shape, orientation and spin of the electron. Okay, bachcho? So let's start to study their types. Quantum numbers are of 4 types: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Principal quantum number is denoted by letter N, azimuthal quantum number is denoted by letter L and magnetic quantum number denoted by letter M, spin quantum number is denoted by letter S. To learn the sequence of these quantum numbers, you can easily learn a trick, PAMS. What does this PAMS means? Here P means principal quantum number, A means azimuthal quantum number, M is magnetic quantum number and S is spin quantum number. Now let's study them in detail. Principal quantum number, it is the main quantum number which gives the 80% information about the electron. It indicates the number of shell in which the electron is revolving. It indicates the shell, radius of the shell, energy, angular momentum of the orbit of an electron in which it is revolving. The value of n always starts from 1, 2, 3, 4 and so on. The value of n can never be 0. To understand this, let's draw Bohr diagram. As you already have studied Bohr diagram in your previous classes, this is nucleus, right? This is the first shell. The value of n for the first shell will be 1. The first shell is also known as K shell, right? And the value of n is 2, the shell will be L. When n is 3, the shell will be M. When n is 4, the shell will be N. Right, beta? So in this way, principal quantum number is basically giving you the distance of the electron from the nucleus. Greater the number of n, greater will be the distance of electron from the nucleus, right? Let's study the next quantum number. Next is azimuthal quantum number. It is denoted by letter L. Now, what does this azimuthal quantum number inform you? It indicates the subshell. The value of L always started from 0 to n minus 1. Let's take an example. If an electron is present in the first shell, that means the value of n will be 1. So, what would be the value of L in that case? 0 to n minus 1. It would be 0. If an electron is present in the second shell, the value of L will be 0 to n minus 1, which means put the value of n as 2, 0 to 1. Now move from 0 to 1. It will be 0 and 1. Two possible values of L are possible here. First is 0, another is 1. For the electron which is present in third shell, the value of L will be 0, 1 and 2. Right? So this quantum number will give you the number of subshells. For the first shell, we have only one subshell. Now, one more thing which you need to remember is the designation of subshell. When the value of L is 0, the subshell is designated as S. When the value of L is 1, the subshell is designated as P. When L is 2, it would be D. When L is 3, it would be F. Right? So let's assign the symbols to these subshells. When n is 1, L is 0, which means which orbital is this one? S orbital, right? And how many subshells are there? For the second shell, one is S, another is P, as the value is 0. 0 means S shell and P means 1, right? Here, how many subshells are possible? S, P and D. Because this S subshell belongs to the first shell, so I should write here as 1. Now these two subshells are from the first shell, so I will write here as 2, and same is the case with the third, right? So in the first shell we have only one subshell, which will be 1s. In the second shell we have two subshells, one will be 2s and 2p. For the same, third will be 3s, 3p and 3d. Now moving to the next quantum number, magnetic quantum number. Magnetic quantum number is denoted by letter m, as we have already studied. It is denoted by letter m. It indicates the orbitals. Now what is orbital? Orbital is the path around the nucleus where probability of finding electron is maximum. The value of Lm ranges to minus L2 plus L. Take an example. When value of n is 1, here the value of n, L and subshell. Here we have ml values. When value of n is 1 means we are talking about the first shell. The value of L will be 0 to n minus 1, which will be 0 in this case. Which subshell we are having in that case? Only S. And ml values will be, ml value will be minus L2 plus L. It will be again 0, right? For the next shell, say we have n is 2. What would be the value of L in that case? 0 and 1. The subshell will be, take the highest value of L. Subshell will be P in that case. Now to count the ml values, just take the highest value of L. It would be minus 1, 0 and plus 1, right? For the third shell, when n is 3, the value of L comes out to be 0, 1 and 2. The subshell will be, take the highest value 2. For 2 value of L, the subshell designation will be D. And how many ml values will be there? Moving from minus 2 to plus 2. It would be minus 2, minus 1, 0, plus 1 and plus 2. So in this way, magnetic quantum number will give you the information regarding the number of orbitals, right? The last quantum number is spin quantum number. Spin quantum number is denoted by letter S. It indicates the spin of an electron. Now what do you mean by spin? Spin means in which direction the electron is revolving around its own axis or around the nucleus. It can be plus half, it can be minus half. Plus half will be when electron is revolving in clockwise manner, and if it is rotating or revolving in anti-clockwise manner, the spin will be minus half. So I hope the topic is clear to all of you.
Yes, ma'am.
Any doubts? So that's all for quantum numbers. Thank you.